We're going to take a preliminary look at long division of polynomials. Not going to cover every possible thing that can happen when you have long division of polynomials, but I'll probably at least mention it all. Okay. First of all, we want to divide the polynomial x squared plus 12x minus 9 by x minus 3. We've written the x minus 3 and then a division sign with the x squared plus 12x minus 9 inside of it. I'm going to make little columns beneath the x squared, beneath the 12x, and beneath the negative 9. To see what those columns are for. But now below x squared, I've got a couple of light lines and a line between x squared and plus 12x, between 12x and minus 9, and then to the right of minus 9 and to the left of x squared. We look at the leading term, the highest power term in the x minus 3 and in the x squared plus 12x minus 9. Well, the leading term of x minus 3 is x. The leading term of the quadratic polynomial under the radical sign is x squared. If we divide x into x squared, we just get x. Now, we write that x above the x squared. And now we're going to multiply x by x minus 3. So we get x times x, which is x squared. We're going to write that underneath the x squared in that column that we created. And then we have to multiply x by negative 3, which gives us negative 3x. And that's going to go underneath the 12x. And draw a little line under the x squared minus 3x. And as in long division with numbers, we're going to subtract what we just got from the original polynomial. Okay, so we're going to have x squared minus x squared, which gives us, of course, 0. And we have minus 12x minus the negative 3x. Minus negative 3x is plus 3x. Adding that to 12x, we get 15x. Now, I recommend, and it's often recommended, that we write a little sign next to the x squared. We have to remember that we're subtracting the x squared from the x squared in the polynomial, okay? So I'm going to write a little minus sign there, just as a reminder. And I'm going to write a little plus sign next to the minus 3x, just to remind us that since we're subtracting negative 3x, we're adding 3x. Okay, now I've got the 15x. I want to divide x minus 3 into 15x. Okay, well, leading term is x, and we got 15x. X goes into 15x 15 times. So we're going to put plus 15 above the 12x. Then we have to multiply 15 by x minus 3, put it down below. 15 multiplied by x gives us negative 15x. And 15 times negative 3 gives us negative 45. Now we see that negative 45 is in the column below the negative 9. And usually we're going to bring that negative 9 down to where it's just above the negative 45. Not absolutely necessary to do that, but it's traditional and we pretty much always do it. Also, when I said 15 times x is negative 15x, I was anticipating a subtraction, and that was incorrect. 15 times x is 15x, which goes right under the 15x. 15 times negative 3 is negative 45, which goes under the negative 9. Now, I'm going to put a little minus sign and a little on the 15, just kind of above it, so we don't mistake it for the actual sign of the negative 15x. And I'm also using a different color. I'm using red chalk as opposed to the white chalk that I'm writing my numbers with. Using red chalk for these little auxiliary signs. And I put a little plus sign next to the 45 so that I don't make a mistake and add two things that need to be subtracted. I've got 15x then, and 15x below that, but I've got to subtract that 15x, so I'm going to have 0 left. And then I've got negative 9 minus negative 45, but that's negative 9 plus 45. I've written that little plus sign to remind myself. And I get negative 36. Well, of course, x, you don't know how many times x goes into 36 because 36 is a constant number and x is a variable number. So the negative 36 is the remainder. So up above the division sign where we've got x plus 15, we can then say big R and a negative 36. Remainder is negative 36. Instead of writing remainder negative 36, of course, we could write minus 36 over x minus 3, just by analogy with long division learned in 5th grade. So we could say that the alternative quotient I've kind of bunched my letters together there, but the alternative form of the quotient. Well, first, what's our quotient? That's what we got above the division sign. You remember that x minus 3 is called the divisor. The thing under the radical, or the thing under the division sign is called the dividend, and what we get is called the quotient. The alternative form of our quotient, which is x plus 15 with the remainder negative 36, could also be written as x plus 15 minus 36 over x minus 3. Remember, when we got to minus 36, we said, well, we can't divide that by x minus 3. At least we can simplify the division by x minus 3 because x is variable and 36 is constant. But we would divide the 36 by whatever's here. And that would give us a fraction 36 over x minus 3. We can't simplify that, but it's perfectly legitimate. Now we can check our division. How do you check a division? Well, if you multiply the quotient by the divisor, you should get the dividend. For example, just to make this very clear, hopefully very clear, if I've got 5 divided into 17, well, 5 is going to go into 17 3 times. 3 times 5 is 17. 3 times 5 is 15. We write that under the 17 and subtract the 15, and we get 2. So the 2 is going to be divided by 5, and we're going to get 3 2/5. Okay. Now we can verify. What's 3 2/5 times 5? Well, 3 2/5 is 17/5. And 17/5 times 5 is 17. So we see that our quotient 3 2/5 multiplied by our divisor 5 gives us 17. So that the quotient multiplied by the divisor is equal to the dividend. Let's check if that's true over here. Okay, it's true for the simple division 5 17. Okay, well, over here, quotient is x minus 3. The dividend is x plus 15 minus 36 over x minus 3. And that should equal, so I'm going to write an equal sign with a question mark over it. It should equal our dividend, which was x squared plus 12x minus 9. On the left, again, we've got the quantity x minus 3 times the quantity x plus 15 minus 36 over x minus 3. We're going to use a distributive law in this form. I'm going to take the x minus 3 times x plus x minus 3 times 15 plus x minus 3. I'll actually say minus x minus 3 times 36 over x minus 3. And that 3 looks really bad there, but that is a 3 in the 36. Okay, again, x minus 3 multiplied by x plus 15 minus 36 over x minus 3 is x minus 3 times x plus x minus 3 times 15 plus x minus 3 times negative 36 over x minus 3. Now we have a little bit more work to do. We've got the first term, x minus 3 times x. Well, that's just x squared minus 3x. And then we have x minus 3 times 15. Well, that's 15x minus 45. And then we have minus the quantity x minus 3 times 36 over x minus 3. Well, if I multiply these as fractions, I'd have x minus 3 times 36 in the numerator, x minus 3 in the denominator, and my x minus 3 in the denominator matches the x minus 3 in the numerator. X minus 3 is the denominator. X minus 3 is a factor of the numerator, so we can divide a factor of the denominator into a factor of the numerator. And x minus 3 into x minus 3 is 1, and that leaves us minus 36. And this finally then equals, we only have one x squared, so we're going to write x squared. And we have just, we have a negative 3x and a 15x, which gives us plus 12x. And we have negative 45, negative 36. And something is wrong because that adds up to negative 81, not to negative 9. So what in the world did we do wrong here? We did the negative 9 and the minus 45. Well, I did add 45 to negative 9, but then I just mindlessly put a minus on my 36. And now my check shows me that that wasn't correct. Okay, it really should have been a plus 36. The remainder should have been plus 36. And when we wrote the quotient x plus 15 with the remainder 36 as x plus 15 minus 36 over x minus 3. It should have been plus 36 over x minus. So in my check down here, I'm going to have to change my minus 36 over x plus 3 to plus 36 over x minus 3. And when I do that, the minus 36 that I got when I multiplied x minus 3, when I did the minus of x minus 3 times 36 over x minus 3, should be a plus 36. And now the numbers work out. I have minus 45 plus 36, and that is minus 9. And now the check works. I'll just put a big check mark down here. And the question mark I had over my equal sign, when I originally wrote the quotient times the divisor equals the dividend, I'm going to put a check mark there, just to indicate that that question has been answered in the affirmative. Okay, well, that's a simple example of long division. We're going to go ahead and do a little longer example with a little bigger polynomial. Okay, we're going to do another example. It's a little longer. 2x minus 5 divided into 4x cubed minus 6x squared plus 7x minus 5. I'm going to go ahead and line off columns under 4x cubed, under the negative 6x squared, under the 7x, and under the negative 5. And then I'm going to divide the 2x into the 4x cubed. Divide the leading term of the divisor, 2x minus 5 is the divisor, into the leading term of the dividend, which is 4x cubed minus 6x squared plus 7x minus 5. Well, 2x goes into 4x cubed, 2x squared times. Now, if we happen to write down the wrong quotient here, if the 2x squared is wrong, we're going to find it out in a minute, because now we've got to multiply the 2x squared by the 2x minus 5 and put it underneath the existing polynomial. So the 2x squared times 2x, 2 times 2 is 4, x squared times x is x cubed. That does give us 4x cubed. And then 2x times negative 5 is negative 10x squared. And that goes under the column under this negative 6x. Okay? Now, I remind myself that I've got to subtract the numbers that I just got, the 4x cubed minus 10x squared, from the original, well, from the dividend, from the dividend. I'm going to put a little minus sign kind of to the left and a little above the 4x cubed, and a little plus sign kind of to the left and above the negative 10x squared, just to remind myself that I'm subtracting. In the case of the negative 10x squared, I'm subtracting a negative, so I'm going to add 10x squared. And I'm going to be subtracting a 4x cubed from 4x cubed. Now this is going to give me 0. 4x cubed minus 4x cubed is 0. If it wasn't 0, it means I didn't divide the 2x into the 4x cubed correctly. If I divided it correctly, if 2x squared is a correct number, then the 4x cubed that I wrote down below the dividend wouldn't match 4x cubed, okay, in the dividend. So those numbers match, so when I subtract, they go away. Okay, I have then negative 6x squared minus negative 10x squared, which is the same as negative 6x squared plus 10x squared, which gives me 4x squared. And just kind of coincidentally, though, we get a 4x squared here. But anyhow, we're then going to divide the 2x into the 4x squared. And that's going to give us 2x. We write a plus 2x just to the right of the 2x squared above our division sign. And then we multiply 2x by 2x minus 5. 2x times 2x is 4x squared, which it had better be. And that matches the 4x squared. So when we subtract, the x squareds are going to go away. And then we do 2x times negative 5, which gives us negative 10x. Now the negative 10x is in the column underneath the 7x. Usually I'm going to bring down the 7x here and write it next to the, write it above the negative 10x and next to the 4x squared that I got when I subtracted negative 10x squared from negative 6x squared, okay? So I can see clearly what I've got. I might write my little reminder signs in. The 4x squared below is going to have a minus sign because we're subtracting. The negative 10x is going to be subtracted from the 7x. That means I have to add 10x to 7x. So the 4x squared and the minus 4x squared give me 0. 7x and the negative 10x is really 7x minus negative 10x. 7x plus 10x gives me 17x. And now I divide the 2x into 17x. What's 2x into 17x? Well, it's plus 17 halves. So let's look. If I multiply now 17 halves by 2x, it's going to give me 17 halves times 2 times x. Well, 17 halves times 2 is 17, so it's going to give me 17x. And I write that under 17x in the column for the x's. Then I multiply 17 halves by negative 5. And that gives me negative 85 halves. Now, that negative 85 halves is underneath the negative 5, so it's going to be subtracted from the negative 5. I'm going to put the negative 5 right here above the negative 85 halves. Then I'm going to mark my auxiliary signs in here. A minus for the 17x and a plus for the 85 halves. Okay? In 17x, subtract 17x gives you 0. Negative 5 minus 85 halves. Well, 5 is 10 halves. I said negative 5 minus 85 halves. Negative 5 minus negative 85 halves. It's negative 5 plus 85 halves. Negative 5 is negative 10 halves. Add that to 85 halves, and we get 75 halves, 75 over 2. That's our remainder. But of course, if we were to try to continue, we'd be dividing the 75 halves by 2x minus 5. So when we write out the quotient, we're going to write it like this. We've got 2x squared plus 2x plus 17 halves. It's going to be plus 75 halves divided by 2x minus 5. Now we're going to simplify that in a minute, but just 75 halves divided by 2x minus 5. Okay, now down below, we're going to do a little scratch calculation. 75 halves over 2x minus 5 means 75 halves multiplied by the reciprocal of 2x minus 5. So that's going to be 75 times 1 divided by 2 times 2x minus 5. That would be 4x minus 10. I can write this out then as follows. I write the dividend 4x cubed minus 6x squared plus 7x minus 5 as the numerator of a fraction. And that is divided by 2x minus 5. And I'm going to say that if I did my calculations correctly, which we can check, that should give us 2x squared plus 2x plus 17 halves, then plus 75 over 4x minus 10. Now we can check that. I'm not 100% sure that I did every step correctly. There are a lot of places we can get distracted and mess up a step. I'm always going to check like I did last time. Last time I found an error. Okay. So I'm going to say what you check, but I'm not going to actually go through the check because we need to do other things. Okay. Minus 5 multiplied by 2x squared plus 2x plus 17 halves plus 75 over 4x minus 10 should equal 4x squared. 4x squared, I wrote that. That's not what I wrote there. Okay, should equal 2x squared plus 2x plus 17. No, started to write the right thing. Equal, okay, this is our divisor times our quotient should equal the dividend, which is our original 4x cubed minus 6x squared plus 7x minus 5. I started to write that out and then decided I'd done something wrong. Okay. So this is multiplied using the distributive law, just as in the first example. Okay, so I'm going to give you one to do yourself. Let's do a simple one. Let's do x plus 3 divided into x squared plus 5x plus 6. Go ahead and see if you can write out the steps and get a result. Okay, now, again, we divide x into x squared. I simply need to know that if you divide x into x squared, don't want to clutter up the board too much, but right up here, x over x into x squared is x squared over x, which is x times x over x, which is just x, because x is a factor of the denominator and x is a factor of the numerator. You divide this factor of the denominator into the like factor of the numerator. Well, that takes care of one of the x's in the numerator, but you still got an x. Okay, so x goes into x squared x times. And then what do? We multiply x by x plus 3. Now I'm going to do this a little differently. I'm going to write x times x plus 3 is going to give me x squared plus 3x. Okay. Now, previously I divided everything into columns, and I'm doing that because there might be visually impaired students taking this as a distance course, and they wouldn't necessarily understand how this works. But when I multiply x by x plus 3, I get x squared plus 3x. The x squared is going to go underneath the x squared. The 3x is going to go underneath the 5x so that they can be subtracted. Put a little auxiliary negative sign next to the x and also next to the 3x. So I say I've got x squared minus x squared, which is 0. And then I have plus 2x, because 5x minus 3x is 2x. Then I divide the x into the 2x. And 2x divided by x is 2. I have 2x over x. X is a factor. The numerator and the denominator divides out, leaves me 2. So up above the division sign, I write plus 2. Then I multiply 2 by x plus 3, giving me 2x plus 6. Now the 6 I've got up here in the dividend, I can bring down till it's right above plus 6 that I just wrote for 2x plus 6. I see 2x plus 6 matches 2x plus 6. So when I subtract this 2x plus 6, and I'll put my little auxiliary negative signs in there, I get 0, so there's no remainder. And I'll write no remainder up above the division sign to remind myself that this is an even division. Okay, x plus 3 goes into x plus 2 with no remainder. We can check. Right? Divisor times quotient equals dividend x squared plus 5x plus 6 with a question mark over it. But since x plus 3 times x plus 2 equals x squared plus 5x plus 6, you just multiply these out using the distributive law. X squared plus 5x plus 6 is exactly what you're going to get. I'll say yes, it checks. Now you can do the steps of the check, but there you have it. Now I'm going to make an observation here. Except I don't have room on this board, I'll have to do it like so. Okay, so we've seen x plus 3 divides polynomial x squared plus 5x plus 6 with 0 remainder. I'm saying it follows that -3 is a zero of x squared plus 5x plus 6. Checking this, plug in -3. X squared becomes -3 squared. 5x becomes 5 times -3, and the plus 6 stays plus 6. This gives you -3 squared is 9. 5 times -3 is -15, plus 6. And 9 and 6 is 15. 15 minus 15 is 0. So you can easily verify that that does give you 0. An important theorem that you encounter in your course, in your actual pre-calculus course, is I'm going to write this in standard notation. If x minus b divides a polynomial, I'm going to say the polynomial is just, we don't know what its degree is. It could be, 5x to the 7th plus 14x to the 6th and all the way down, okay? But I'm saying a sub n, x raised to the nth power, plus a sub n minus 1, x raised to the n minus 1, plus, well, the pattern continues. You would get an minus 2, x to the n minus 2, and so forth, until you finally get down to a1x plus a0. That's just a general way of writing out a polynomial, okay? If x minus b divides this polynomial, then b is a zero of that polynomial. We could also call it a root of the polynomial. A zero of the polynomial is a root of the polynomial. Okay. As an example, we just saw that x plus 3 and let's be careful. When I say this divides the polynomial, what I really mean is it divides it without remainder, okay? So I'm going to emphasize without remainder. Although it's not absolutely necessary to say without remainder. Right now, we want to remind everybody it's without remainder. We just saw that x plus 3 divides x squared plus 5x plus 6, a remainder. So I'll write differently. Since x plus 3 equals x minus negative 3. X minus 3 must be a root or a 0 of x squared plus 5x plus 6. And of course, we just verified that it's so, but it's so for any polynomial. Now, there's a way that this is used to help factor polynomials, but we don't have time to go into that. And I think it would be a little bit confusing because we had a little bit, had to work a little bit to make sure we understood how these things go together. And I don't want to overload anybody, even though I do it every day. Okay. So practice that. It'll do you some good very soon in your pre-calculus course.